Hello, everybody. I hope you can hear me. Looks like I'm set up. All right. Hello, this is Jan. I'm from Typefox and Gitpod, and I'm going to present you this talk on Beyond LSP, getting your language into Theia and VS Code. Welcome. So what is the topic of this talk? The requirement is you want to create your own programming language, and that programming language should be textual. And you want rich text editor support for it. That means code completion, link following, and so on. Because if you create a new language, your users will need some kind of tooling in order to understand it, and must be guided to understand the language. And in addition to that, I mean, this is the example language we use here is a state machine language. You want to have diagram support. State machines can be very nicely drawn in diagrams. And it would be nice if these diagrams would be automatically synced with what you type, what the user types in the text editor. And we want to have the entire thing as a VS Code extension. I gave similar talks about this topic before for Theia, for Eclipse, RCP, and this time is VS Code extensions. But VS Code, that's Microsoft, isn't it? So is this EclipseCon? Yes. So if you want the maximum reach for your language, you should maybe target an IDE with a big market share, and Visual Studio Code actually is that. But in addition to that, even if you're coming just from the Eclipse side, want to use Eclipse Theia, the new way and the only way now to add a new language to Eclipse Theia is via VS Code extension. So Theia understands VS Code extensions, and that's why this is a good idea to also cover this topic on an EclipseCon. And of course, all the cool new web IDEs and workspace provisioning frameworks like Gitpod are based on Theia, so this will also work in these. So let's have a look. This is the architecture I'm going to go through. It's a bit complicated at the first glance, so I will split it up in smaller parts. But what you see is that there are a lot of technologies involved. So there's NPM, there is VS Code APIs, there are TextMate APIs, and there are even Xtext and Sprotty involved. And I come to these in more details. All right, let's start with the simplest thing first. A VS Code extension has one part that is only declarative, that's mostly specified in JSON, and we'll cover what's in there. A VS Code extension is basically an NPM package. If you've never done any JavaScript development before, NPM is a bit like Maven for JavaScript. So this is a package. Packages can have dependencies to other packages. That's also the way how VS Code extensions can have dependencies on other VS Code extensions. And you define some metadata, name and version, and where's the repository and so on. But also, in addition to that, VS Code has extended the schema such that you can add VS Code configuration. And that is, for example, commands and bindings and menu entries. That's pretty similar to what you would do in an Eclipse RCP in a plugin XML. But last but not least, these you can contribute a language. And you see that on the lower side of the snippet, that contributes languages. We contribute a language that's called states with the file extension SM. And it has two configuration files with it. That's the language configuration, which gives you some editor hints for what is a comment, what should I do when toggle line comment or toggle region comment is hit by the user, or a grammar. And the grammar is a TextMate grammar. This is only used for syntax highlighting. So this is completely declarative. If you've never seen a TextMate grammar, the TextMate grammar has these match statements here. These are actually regular expressions. And for example, you see there's a match state machine state event. So these are the keywords which should be highlighted in a special color. And the color is not directly specified, but there is a keyword controlled states. And that is then mapped from VS Code to some VS Code key, and that one is looked up in the current theme that you're using in VS Code in order to map it to a proper CSS style. So does that work? Let me give you a short demo. Here you see VS Code. We have exactly the grammar that you've seen on the slides. We have a package JSON, which registers the language as defined before. And now we do the same as with Eclipse RCP development. We start a new VS Code with this extension installed. So this is the new runtime VS Code. And you see, oh, well, here's already an example file that I prepared. So you see the state machine, the events and the states, and you see there is syntax highlighting. And that comes exactly from this configuration that I showed you. There are other things that work already because I have also this editor configuration. That would be, for example, toggle block comment. So we'll surround this with a block comment. That syntax is also defined declaratively. But there's not much more. So if I do a syntax error, I get no hint. If I do a linking error, so this is a cross-reference to something else, I get no hint. So this is pretty poor support for language. What can we do to improve that? Well, let me show you. Just a second, I want to add my spotlight pointer. All right. So now I can use a pointer, that's better. Okay, VS Code has a special API for adding language support to a VS Code application, and that is called the Language Server Protocol. I could talk hours about that thing. What you have to know is it is basically a protocol, so you can implement it in every kind of language you want to have. It's based on JSON, RPC, and it consists of a lot of callbacks from the IDE to some service that has the smartness about the language. For example, I toggle content assist in the IDE, and then a language server gets notified what's the best content assist at this place, and it analyzes the file that you have and says, okay, you could, for example, enter this keyword here, and that is returned to the IDE and then generically rendered to the client. This is a very good thing, but the question is, how do I get a language server? Because that seems to be quite a lot of work. And the good news is there's a framework for that, and that's called Xtext. Xtext has been there around for quite a while, over 10 years. It's an Eclipse project, it's all open source, and the speciality about Xtext is you just define a grammar, very similar to a enhanced Bacchus-Naur form, and from that derive a complete language server, just automatically generated. Let's have a short look at that grammar. That grammar consists of these entry rules, state machine. There is a state machine keyword, and then an identifier, and then we have a couple of states and events. And these also have identifiers and further events, further elements like a transition. And finally, this transition has two cross-references, so it can refer to events and states that are defined somewhere else in the diagram. So as opposed to common language grammars, even cross-references are covered here. And from that, Xtext automatically generates the entire language server. That's really the only input thing that you need. So now you have a language server, but that's basically a CLI tool. So you have a start script to start the language server, and then it listens to input on standard in and to perform some output on standard out. So you have to hook it up to your extension. And then this is the place where you have to go from declarative to programmatic. That means you have to write a little bit of code, and that is the activation code. First of all, you register a JavaScript module as the main entry point for your extension, and then you implement the two lifecycle methods from the VS Code API inside that module, that is activate and deactivate. And within activate, you start the language server as a CLI application and connect it using a so-called language client. That's the Java, the TypeScript equivalent on the, well, the TypeScript endpoint that's communicating to the language server. So let's give you a demo. How that is looking. Where is it here? Should be this one. Okay, so this is the same example running here. Now you have syntax errors because it no longer is no longer compliant to the grammar. You have linking errors. You can follow links by control clicking. You can even do a rename refactoring. And you see that not only the declaration, but also the cross-reference to it is updated automatically. And that would happen across many files and so on. So there's really not much you have to do with Xtext to get a very, very powerful tool. All right, so much for the text. How about graphics? I promised some graphics, so let's go on. How do I get graphics into VS Code? So the language server protocol only talks to this generic text editor client that you're seeing here on the left. But if you want to have some different GUI, like a diagram, you have to use a WebView, and that is basically, I mean, VS Code itself is a web application that runs as a rich client, but it's a web application, and this WebView is a separate application within that application. It's realized as an iframe in the DOM, and it's completely separate. It has a very thin communication API, which allows it to communicate back to the extension that spawned it. But within the WebView, you're completely free how to implement that. It's just an HTML page, so you can add JavaScript stuff and so on. But how would I specify a diagram in that? We would use the Sprotty framework in this talk, and that is a web-based diagramming framework, also hosted at Eclipse. It has a reactive architecture, that means pretty close to React for Flux, and that means a unidirectional flow of events, much easier to debug some errors in the GUI. And last but not least, it is client-server capable. That means it has this cycle here, where the action, this is the user events, are converted into commands and then executed, and then the viewer is updated. But you can also feed in some actions from the outside, for example, from a server. And this is what we're going to use in the following. Sprotty comes with various adapters. First of all, we're going to use Sprotty itself for the diagram client to render and for the GUI. Then we need sprotty-xtext to connect the whole thing to Xtext. And finally, we need Sprotty VS Code in order to glue the entire thing up in VS Code. So 3 parts of Sprotty that I used. If you want to understand how Sprotty works, this is a very, very short intro on that. Sprotty internally represents the diagram as an S model. An S model consists of a graph with nodes and edges and ports and labels and compartments and the like. This is completely customizable. So if you don't want to use graphs and nodes and other things, you can have your own concepts. So this is very generic at this place, but this is what you usually start with. And it is serializable as JSON, such that we can send a new S model over the wire to all kinds of components, which we are going to do in the following. At the heart of a Sprotty application, there's a DI configuration. So Sprotty uses dependency injection. And in this DI configuration, you can bind all kinds of services to specific implementations. There are a lot of defaults, so you don't have to do that from scratch. But what you have to add in addition to that is a mapping definition from the S model to the views. And the view in Sprotty is the rendering element. So as you see here, a node is mapped to a view, and a label is mapped to a view, and an edge is mapped to a view. This is how Sprotty knows how to actually render an S model. You can also customize behavior using these features. So we made that composable. That means that you can add all kinds of features to call all kinds of S model elements, like in this case, hover and pop-ups. they're also default features, so you usually don't have to touch that. All right, so we're going to use Sprotty to populate the view, but where do we get the S model from? And of course, the S model comes from the language server, because the language server is the only component here that knows how that text that's rendered in the editor is actually to be interpreted. So it takes the text, parses this into an Xtext model, and then takes that Xtext model and should turn it into an S model. And this is what is going to happen next. In order to deal with that Sprotty extension, we added some notifications to the language server protocol that allow to send actions and receive actions from the outside. So this is really in order to encapsulate the communication from the Sprotty component to the language server. We have to encapsulate that in LSP, and this is what we do by adding two methods. The other thing that we have to add is a diagram generator. This one is automatically hooked up into the Xtext framework in a way that is bound to the life cycle of the text models that we have in the editor. That means each time the user changes the text, the parser kicks in and transforms this, parses this text into a model, which we call the AST or the Xtext model in this case. And that model we use then to derive an S model that should be the representation of the diagram. And the component that does that is called the diagram generator. So this is something that I usually implement in Xtend, because it's very nice. Xtend is a nice language to do this kind of mapping, but any kind of JVM language will do. So now we have the language server that has a diagram server and that has this diagram generator, and it sends some LSP messages here. And this is extended LSP with these two methods that I just shown you. How do we make sure these messages are actually processed somewhere? And this is where Sprotty VS Code comes in. We have one component that's called Sprotty VS Code, LSP extension, that connects to the language client and listens for these kinds of notifications that we added, extract the action in it, and send it on to the VS Code diagram server, which is the other part of Sprotty VS Code on the other side in the web view, using the generic VS Code web view communication channel. So it's all about tunneling actions from the language server down to the web view. I guess that is what I just said. So to illustrate that, here's how it works. User types in some text in a language server connected editor. The new text gets over to the language server. The language server takes it, parses it, creates that Xtext model. Then the diagram generator takes that Xtext model, transforms it into an S model. So here are the nodes and edges and so on. Oops. That one is converted to an update model action, so wrapped into an action by the diagram language server. That one is turned into a notification and sent to the language client using the new dispatch update model action notification that we added to the language server protocol. On the language client, we have a listener on these kinds of notifications, and that is the Sprotty VS Code LSP extension. That one extracts the update model action from the LSP request and turns it into a message that is then sent to the VS Code diagram server. And from there, fed into the cycle of Sprotty, and so it is rendered. What does that look like? Let me give you another demo. So this is a the text editor that we've just seen. I have now a new action also provided by Sprotty VS Code to open this in a diagram. And you see every state has become a node, and every transition has become an arrow, and every transition on that arrow has become a label. you automatically get selection synchronization. So when I click in the diagram, it takes me to the text and the other way around as well. And what is very nice with Sprotty, it's all pretty smooth. So let's add a new state. And you see, as soon as it's there, as it's finished, it is created here, and there's nice animation that guides the user's eye to the new state. So when I now add another action, you see it works. Okay. Good. I guess did I show everything about Xtext? I'm not sure. Yeah, I did. Okay, one more thing is you can actually take this one step further. And this is also what I did in this example. The example code is online already, so I give you a link to that later on. But so far it was, the text model was always leading. That should always be the case when you're working with Xtext, by the way. But of course, you can turn user actions on the diagram side into LSP actions. And that would be, like in this case, when I double click on this node's name, for example, I will trigger an LSP rename refactoring in order to change that. And that can be done for all kinds of things like this cross-references here. So you'll be using code completion in order to get these candidates and so on and so on. So you can even take this further, be a bit careful about that. I have had a couple of presentations on this topic. You'll surely find something in the web from me on combining text and graphics. Okay. Let me give you a few more notes on the development process. First of all, well, yeah, apparently we have a microservice architecture. So we have the extension itself, we have another application running in this web view, and we have the language server, which is yet another process. How do we debug all that? It's actually quite simple. So the extension code itself can be debugged with the normal means of VS Code. So you just set a breakpoint in the extension code, and the IDE will stop when that point is hit. The language server, there is a special thing you could do. I mean, it's a Java application. You could attach a remote debugger, but we also have a language server socket in Sprotty-Xtext that allows you to easily to keep your server running, for example, from Eclipse. And this is then easy to debug from within Eclipse. Last but not least, there's the web view. I may want to show this to you. So how do I debug the web view? In VS Code, you can always hit F1 and you see all the commands. And one of these commands is this one, Open WebView Developer Tools. And this will open the debugger from the Chrome debugger. And now let's here, for example, this is the action dispatcher part of Sprotty that kicks in when an action comes. So when I pop over here, you see this action is hit and I hit the breakpoint. So as it's a separate application, it's a separate debugger. Okay. Webpack. Yeah, in JavaScript, usually you have more than one JavaScript file. You're using Webpack in order to pack things up. It's a little bit tricky to get the source maps right. I would propose just to look into the example code if you have any problems with that. And finally, once your extension is ready, you want to publish it. You could use the VS Code Marketplace, but unfortunately, only Microsoft products can connect to the VS Code Marketplace. So from Theia, Gitpod, VS Codium, it's not allowed. And that's why there's a new project. And that's called OpenVSX. It's also an Eclipse project. Such an OpenVSX registry can be installed on your own premises if you don't want to make your extensions public. And there's a public instance that's going to be run by the Eclipse Foundation soon. It's the default for VS Codium, Gitpod, and Theia. All right, that's all from my side. I guess I'm almost exactly on time. So here are a few links. Especially the fat one here is the example that I showed in where all the steps are separate commits, so it should be easier to follow this one. All right, I see there are a couple of questions. Are there any plans for an Xtext to TextMate Grammar exporter transformator? Not that I'm aware of, but these are all open source projects, so we are open for contributions. By the way, TextMate is also understood with certain plugins in Eclipse. The second, is there a way to use X-based Java integration with an LSP? X-based is not supported yet, so no one has done that, has converted that into an LSP. For Java, there is an LSP, of course, provided by Red Hat. Does Sprotty LSP differ from standard LSP? Yes, we add these two methods, accept and dispatch, which allow to send and receive Sprotty actions via the language server protocol. That's the difference. Does Sprotty LSP allow to transport and persist node location sizes and so on? That's a very good question, because what you've seen was automatically layouted using the ELK framework, also Eclipse open source. But for most applications, users may want to move nodes around and reroute edges and so on. You have to store that information somewhere. It's technically feasible in Sprotty, but you have to store that somewhere. And then you can, for example, add that in the Xtext language itself. We had customer projects where we did this kind of thing, or add another file where you store this. That's the basic thing, but the UI is there in Sprotty. Okay, LSP is activated and deactivated each time the document is opened and closed. That's right. And not really right. So if the last, as far as I know, when I close the last file of a certain language, then the LSP is shut down. And even that does not really always hold. So I'm not sure what to answer to that question. So the question is whether we can keep the LSP alive somehow. We have built prototypes where we start the LSP eagerly right on start and keep it running for the entire time. That is definitely working. I hope that answers the question. Last question, can you quantify how much of the LSP functionality in your example is provided declarative via Xtext VS Code? What do I have to do to make the node rename in a diagram work? Yeah, the node rename, which is the connection between the LSP and the diagram, so where the diagram actually calls LSP. In this case, is part of Sprotty VS Code, actually, the basic infrastructure for that. What you have to do is you have to use a specific type for the node. So each S model element has a type attribute, and that has to follow a certain naming pattern. And then it should work. All right. Okay, but of course, these kinds of integrations, like calling LSP from the diagram, they're a bit deeper, and you may want to customize it a little bit further. But yeah, all the code is online. In this VS Code Xtext Sprotty example, it's also the example that we ship with Sprotty VS Code. So there you always find the very latest version. I cannot ensure that this is always kept up to date. But within Sprotty VS Code, it is. Okay. Good. Yeah, so if you like this kind of tool stack, of course, Typefox is looking for new employees, so we hire. Feel free to contact me. Other than that, it was a fun giving this presentation. Stay safe, stay healthy, wear a mask, keep the distance, and enjoy the rest of the conference. Thank you a lot for your attention.